We're going to do some relatively complicated problems here. When we look at problem one, we have f of x and g of x as given. I already have them graphed to save some time, and I put some points for f of x there because we haven't taught how to graph parabolas yet. But if you just substitute some values in for x, you get those values out for f of x. So if we take a look at the domain of f, the domain is as we move from left to right, all of the values that we can substitute in for x. There are no values that we can't substitute in for x. So we get negative infinity to infinity. The range for f are all of the y values that can come out. And if you notice, we can't go any lower than -5. So the range is -5 to infinity. Notice that this is a bracket over here, and that's a parentheses. Sometime I'm uh, using a tablet to write, and it's not as easy. Okay, the domain of G and the range of G are negative infinity to infinity. Those are pretty simple. As we look at f of G, so one thing that I want to make clear is that f little o g is the same thing as f of G of x. Likewise, g little o f is the same as g of f of x. We do the inside first, and then we do the outside. It's kind of like moving from inside to out. So when we look at this, we're doing f of g of x. Sorry, I'm missing a parentheses. That's the same thing as f of 3x minus 2, which is the same thing as 3x minus 2 squared minus 5. So notice I substituted g in where x was in f of x. Now if I wanted to do the distributive property on 3x minus 2 squared minus 5, I could. And I'll do that real quick without doing all of the work on the paper. It's 9x squared minus 12x minus 1. But we'll probably use this form of the answer to do most of the problems because it's easier to use. So if we're doing f of g of 2, in this case, when we look at f of g of 2, we can do this in a variety of ways. We can take this function that we just found and substitute 2 directly into this function. So 3 times 2 is 6, minus 2 is 4. 4 squared minus 5 is 16 minus 5, which is 11. We also could have done this by taking g of 2, which is 4, and then doing f of 4, doing that over here. And if we did f of 4, we would also get 11. We can do that in a variety of different ways. Now if we take a look at g of f, once again, that's the same thing as g of f of x. So I'm going to substitute f of x in here, and now I will have g of x squared minus 5, which is the same thing as 3 times x squared minus 5 minus 2. It's definitely easier to continue simplifying this. This will end up being 3x squared minus 15 minus 2, which is the same thing as 3x squared minus 17. So if I take g of f of 2, I can substitute 2 into the final answer, and I will get 3 times 2 squared, which is 3 times 4, which is 12. 12 minus 17 is negative 5. I also could take f of 2, which is negative 1, and do g of negative 1. And if I take a look at g of -1, I would also get -5 after I substituted -1 in. Now, the last part, if we want to look at the domain and range of f of g and g of f, it's probably easiest to look at these answers. So if I'm looking at the domain of f of g, look at all of the values of x that I can substitute in. I can substitute any value in to this function. So -infinity to infinity. The range are all of the values that can come out. Notice that this part, the smallest it can ever be is 0. 0 minus 5 is -5. But this has no bound on how big it can be. So my range is -5 with a bracket to infinity. The domain of g, I can substitute anything in that I want. So I have -infinity to infinity. Sorry, g of f. I meant to say domain of g of f. The range of g of f, the smallest this can be is 0. 0 minus 17 is -17. And the biggest that it can be is infinity because there's no bound on it. So -17 to infinity. We are going to take a quick look at the graphs of problem 1. If we look at the graphs, these are the graphs that we saw earlier. Now if I take a look at f of g, that appears to be 3x minus 2 squared minus 5. Notice that the domain of f of g is -infinity to infinity. If I scroll out, it will keep going. It's just going to grow really, really fast. But if I kept going, it would end up going to -infinity to infinity. Notice that my range stops at 5. It's exactly what we predicted it would be. If I look at g of f, it appears to be 3x squared minus 17. Notice that my lowest range value is 17. My domain goes -infinity to infinity. There's nothing that I can't substitute in. Let's take a look at problem 2. Notice once again I have them graphed already for saving time, and I have some points that I can substitute in for g of x. Notice if you substitute in anything less than -6, you get an error because you can't have a square root of a negative number. So if I take the domain of f and the range of f, they are both -infinity to infinity. I have no issues with any values coming in or out of that function. The domain of g, I have a bracket -6 to infinity because I can substitute in -6, but nothing less. And then the range, if I look at the graph, 0 to infinity comes out. If I look at f of g, that's f of g of x. So that's the same thing as f of the square root of x plus 6. So if I substitute that in, I get 2 times the square root of x plus 6 minus 6. I'm just replacing x in f with x plus 6. And sorry, I forgot. I probably should have shown what I was doing. I'm using a simpler form of f of x by multiplying and using the distributive property, not because uh, point slope form is exceptionally hard, but because in this problem I think this is a little easier. Now, f of g of 2, um, I'm just going to substitute 2 in here. I get 2 times the square root of 8 minus 6. For those of you that remember how to simplify square roots from geometry, we have the square root of 8 is the same thing as 2 times the square root of 2. So I can rewrite this as 4 square root of 2 minus 6. G of f is the same thing as g of 2x minus 6. So I'm going to replace x in g with 2x minus 6. So this becomes the square root of 2x minus 6 plus 6, notice that this right here, the 2x minus 6, um, that was something that we just substituted in where x was. And then if I simplify this, I just get the square root of 2x. I cannot simplify this any further because the 2 is on the inside of the square root. So if I take g of f of 2, I'm substituting 2 into this equation. I get the square root of 4, which is 2. Finally, the domain of these functions. If I take a look at f of g, if I substitute, or what can I substitute in? I can only substitute in values that are larger than -6. So bracket -6 to infinity. The range are all of the values that could come out. If I take a look at this function, the smallest this can be is 0. -6 means that my range is -6. And then I can go all the way up to infinity because this is not bounded as I plug in larger and larger numbers for x. For g of f, my domain is from 0 to infinity because I cannot substitute in anything smaller than 0. And my range are the values that come out. It is also 0 to infinity. Looking at problem two's graphs, if we take a look at f and g, they're exactly like we said they were. Now, if we take a look at f of g of x, notice that my domain and range are both bounded by -6 for x for the domain and -6 for the range for y. And there's no limit on either the x or the y value. If we take a look, sorry, I needed to show that it was 2 root x plus 6 minus 6. Now, if we take a look at g of f of x, that is square root of 2x. Notice they're the same. And notice that the boundary, the domain and range are both 0 to infinity. It stops at 0 for both the x and y values.